now. And this one is the one you're supposed to be doing. And if you did this, you get negative 6y plus 6 equals to 4. Combine like terms here. You get 6 minus 6y. It is the same. Notice they're the exact same thing. I don't know what that was about. Notice these are the same. So they're infinite solution. So if you want to prove it, infinite solution. Coefficients are the same. Okay, we go to here. I didn't have time to explain this. Okay, this, you need to do this here. You break this up as 4/25 and then square root of 6. Okay, the square root of 25 is a perfect square. It's rational. This is called a rational number because it's a perfect square that's rational. Is 5. And times the outside number of 4, this is times, that's 20. So my answer is 20 for the number. This you divide by 2, you get n to the third. So 20n to the third is your answer. Okay, for this one, same thing. Negative 2. Now the square root of 36. Square root of 36 is 6. Multiply them together, you get negative 12. And n to the 10th, n to the 10th is divided by 2, you get n to the 5th. That's your answer. Here, 36 is, square root of 36 is rational. Here, square root of 8, n to the 10th, square root of 8 is 4 times 2. 4 is 2 times 2. Okay, so you get square root of 2 times 2 times 2. 2 to the, or that's how I teach my other class, okay? You guys, I taught it this way. 8, square root of 8 is 4 and 2. Square root of 4 and square root of 2. Well, 4 turns into 2. Square root of 4 is 2. Okay? Square root of 2 is irrational. Irrational means not a perfect square. This is not a perfect square. Square root of 8 itself is not a perfect square because put it on a calculator, you get decimals. So it's called irrational. Square root of 8 is irrational. Square root of 2, divide this by 2. So you get n to the 5th. So 2n to the 5th square root of 2. That's your answer. Okay, rational numbers are perfect square. That's what I need you to remember. There's more to it than this, though. Rational numbers are perfect squares. Irrational, like square root of 36, square root of 25, square root of 16, 4 times 4. Irrational are anything that's not a perfect square. Square root of 2, square root of 5, square root of 6, square root of 7, square root of 8, not square root of 9, square root of 10, square root of 11, all those are irrational. Okay, so remember these. Product power rule. Add these together. You get p to the 0. Okay, and then you multiply these together, that's 21. P to the 0, anything to the 0 power is 1. So 21 times 1 was 21. Subtract them, m to the second. Quotient power rule. We subtract. Okay? When their bases are the same, you don't divide them. So if I have subtract them, same base, subtract them. So you get x to the, this is invisible 1, fourth, because 5 minus 1 is 4, and y is 4 minus 4 to the 0. Anything to the 0 power is 1. So x squared times 1 is just x to the 4th. X to the 4th times 1 is x to the 4th. Is my answer. Right here, you distribute. So 1, 6 to the negative 2, m, negative times a negative is a positive 6. Now, this one with the negative exponent has to move to the denominator. Okay, so that becomes m to the 6th and 6 to the 2nd, or the answer is m to the 6th over 36. Okay, here, make a table and graph the following equation when the range is the following. Range, remember, is the y. Range is the y. So we got y. You substitute here. Here's the input, output, domain, and range. We got the range of -5, -1, 0, 5. We need to find the domain, the x. So the range is 5, so you got x plus 2 equals the absolute value of y. That's the problem given here. Now in the y spot, we substitute it with the -5. Okay, now absolute value of -5 is 5. You cannot solve it until after you take the absolute value. X plus 2, x minus 2, x equals to 3. So your ordered pair here is 3, because x is 3. 3 comes first. X comes first, then y. Then we need to substitute in -1 for y. We have x plus 2 equals to absolute value of y. In place of the y, you put in -1. Absolute value of -1 is 1. X plus 2. X equals to -1. So it's -1 from here, and this -1 there from the y. Next one is 0. X plus 2 equals the absolute value of 0. Absolute value of 0, 0. X plus 2. X equals to -2. The last one is 5, and I don't have enough room, so I'm just going to do it right here. I want the order pair to graph it. X plus 2 equals the absolute value of y. So I replace the y with 5. Absolute value of 5 is 5. So this is 5, 3. Oh no, it's the other way. This is x value. 3, 5. Okay, so you got 3, 3, -5, negative 1, 1, negative 0, 2, 0, negative 2, and 3, 5. Okay, this graph, is this graph a function or not? Not a function because the vertical line goes through the graph twice. If you had to draw a vertical line, it will go through that graph twice. Oops, sorry. Oh my gosh. So not a function because the vertical line goes through the graph twice. Okay. Last one is same thing. Range. We know y. I'm going to give more room for the y's because y, x, I mean. Negative 10, 0, 5, 10. You substitute in range as y, knowing that x, this is, you're trying to value of x minus 2 equals to absolute value of y. So in place of the y, I put the negative 10. And continue to solve that way. Domain is x. So when you have this, x, y, these number goes into x. Negative 4, 0, 4, and 8. So your problem is 2 equals to x plus y. So you got x is 4. Oops. X is negative 4. Plus 4 plus 4. 6 equals to y. Okay. So your ordered pair is 4, 6. So you put 0. I got it wrong. Oh no, got it wrong. Look, absolute value right here of x. So that's 4 plus y equals to 2. Oh my goodness. Someone almost earned a homework pass. Minus 4 minus 4. Negative 2 equals to y. So negative 2 equals to y. Y is negative 2. Now you have the same problem. You got this problem here. 2 equals to absolute value x plus y. Okay, I'm tired. You guys know how to do the rest. 0 plus y. So 0 plus y is y equals to negative 4. Substitute in 0, you get negative 4. Substitute in x is 4, and then solve it. You do the rest the same, okay? I don't know why I'm so tired.